Okay, welcome, folks. This is, again, Joseph Barletta and Mr. David Lederberg here with Supercharger America. We're going to be discussing all things dealing with Tesla's new V4 supercharger cabinets. Some pretty exciting news. I'm sure you guys would love to hear about it. Again, you can find us at smartchargeramerica.com. If you have any questions, we'd love to hear some of your feedback. Other than that, David and I are going to go and discuss just, kind of ad hoc on what this means and kind of how we can anticipate this. Of course, you're looking at the new V4 supercharger cabinet. Pretty exciting. It supports NACS, CCS1, 2, and GB, which is a Chinese-based, Asian-based DC fast charging protocol out there. So, we can actually start to see that we're going to see these cabinets actually installed in the European markets if they're going to be able to come with the CCS2 and 1. I thought it was interesting on the CCS1, basically maybe for some qualification criteria with the NEVI funds or as the world transitions, as the US actually transitions from CCS1 to NACS. I thought it was pretty clever that they have the ability to support those connector handle types. So high power density, compact footprint, very, very nice. One of the unique things on this, David, that was, it basically is kind of overlooked, is that each one of these cabinets supports 8 stalls, as opposed to the regular V3, where each cabinet supported only 4 stalls, right? So now you're having greater expansion, more stalls per cabinet that you're able to put out on site, and that's huge. Another thing was the high efficiency, low noise cooling system. This thing's got 4 giant, if you look at these, watch. Look at these giant fans on top of these things. 4 giant fans that are literally whisking the heat away. Heat rises, right? So as that heat rises, let's get it out of here. So I thought this was a pretty clever design on having the fans on top instead of kind of in the rear, on the bottom, on the side, if you ever see those things. What do you think of that? Have you seen other DC fast charging cabinets with the fans on top like this?
Yeah, I mean, what's interesting here is that it specifically talks about the cooling specs, that it's very quiet. So some of these cabinets can just get rip roaring loud with the fans going. It needs a lot of airflow, but with a higher efficiency, you got less heat waste, and that is good. So less energy converted to heat and more energy put into the vehicle, which is really key here. So you can even see they have a spec as far as the loudest it gets, and it's extremely quiet. We're talking, 60 dBA max noise at 1 meter at 30 degrees Celsius. So ultimately, what does that mean? It just means it's pretty quiet. Doesn't mean it won't get loud, but obviously it depends on the heat and whether it's cold out or hot out, how the workload of the unit. But in the grand scheme of things, yeah, it's got multiple fans that probably run at lower speed, maybe on a more consistent basis, that allow for more airflow and less noise in the process.
Heard that. Now you see what Tesla's done with the, I guess, the refresh model of the Model 3 and how they, the old Model 3 and the new Model 3 is just, they've refined the noise, the quality of the ride, all of that stuff. I'm wondering if they possibly, from some of the learnings that they've done with literally the Model 3 refresh, if they put that into actual the cabinets. Now that's a far-fetched idea, but if you're saying that it's more, I think it's a 2% higher efficiency between the V3s. And so if you look at that 2% efficiency improvement across the board, I mean, if superchargers are already delivering over 5 terawatt hours of power per year, that 2% could yield like hundreds of gigawatt hours of storage of power and waste. Basically, that's what it's saving, right? So that's where like these small incremental changes that Tesla's so, I guess, well known for, as they scale, each one of those incremental changes is huge with regards to the magnitude of the impact that it actually makes across the industry. So that was pretty exciting. Global voltage input rate, range, I guess, what is this? Global.
They misspelled range.
Range. Okay, they misspelled range. Look at that. We caught an error. Let's send that to Tesla. We'll let those guys know. Okay, rugged enclosure for all environments. I see the swing cabinet, the door here. It is a little wider. I do like the clearance. We'll talk a little bit about the clearance on that end. Surface mount wiring options. I do like that. Surface mount wiring options, and then high power factor, low harmonics. The harmonics is a big thing. You know, a lot of people were asking us if the level 2 systems like the ChargePoint CT4000s or our SCA40 units, if they actually experience harmonics. And we're like, no, you don't really get a lot of harmonics with, you know, level 2, 240 volt, you know, 208 volt, you know, chargers, but you may possibly get some harmonics and some interference there with DC fast charging, especially at such a high rate. And so it's really good to see that the high power factor and low harmonics here. Be curious to see what ratings on their harmonics that they actually have. But let's get into the technical specs. And so, you know, one of the things on the DC post output, we noticed, we visited the V4 stalls, and we've seen that, yes, they do have voltage ranges between 180 and 1000 volts. We were really excited to see that because, you know, we knew that what that had the capability of actually turning into. The problem is the cabinets behind the fence were V3 cabinets. They were never the V4 cabinets. So we were not sure really how the power of the V4 cabinets would align with the output post, or I guess you could say the post output. But we can see that it's pretty close. I mean, you know, between the ranges, I mean, 615 amps. That's what we're getting on the post output on the electrical. Number of charging posts, 8 maximum. So 8 maximum per actual cabinet. And we talked about that and the viability and what that's going to be able to do for expansion. So it's more stalls available with less input on the electrical side. And so that just adds more people can get served with the same amount of effort that we're putting in, you know, and cost on construction of these sites. So as far as AC put on the electrical, you know, the AC side, I'm seeing what, 480 volts or 1200 amps there. That's good. The frequency at both 50 and 60 tells us, you know, that they absolutely are going to be using this in Europe. European market actually has 50 hertz, and we're at 60 hertz here in the US. Power factor, you can see that is greater than or equal to 0.99. So that's pretty interesting on there. What are some of the things that actually stand out to you on this particular cabinet, like the technical, you know, specifications on this cabinet?
Yeah, I mean, I love the input flexibility. That's just going to make it extremely easy for Tesla to maintain a single production line, or, you know, a cohesive production line, and output a single unit that can be installed anywhere. So that's extremely capable and makes it just easier overall. It looks like, you know, high amperage up to 1500 amps at the 480 volt, and that's where you get the almost 1.2 megawatt output capability. Other things that I noticed, you know, were quite a few inputs, you know, and another thing about the unique thing about the wire here is that the typical wire that's installed for pedestals and just supply power cable in general tends to be 600 volt rated, meaning that the power going through the cable cannot exceed 600 volts, which is fine for a majority of cases. But if we're talking a situation where the pedestal could be up to 1000 volts, it's going to need 1000 volt rated cable. So there will be probably instances, I could tell you with like an install that we did for Tesla, that we did 600 volt rated cable. So if that's going to be upgraded to the V4, that wire will need to be pulled out and repulled.
Yes.
So with 1000 volt rated cable, that might be the case for a number of these. So it's not necessarily always going to be as easy as swapping pedestals and swapping cabinets. You know, there'll need to be swapping of cable as well. And so that could take a little more time, perhaps. But other than that, I mean, I could see the communication protocols are all there, up to 1000 volt ratings. And then I think the only other thing I saw that a lot of these standards that they have are pending, like whether it's UL or CSA, GPT. And I think they just need to wait to get that until they're fully out. But it is expected to be installed in 2025. It's just where will it be first, and you know, probably these UL will be necessary as well.
Now I'm wondering, have you gathered information from the Tesla Supercharging team that we're in talks with, you know, basically on a daily, maybe even on a weekly basis? Have they shared with us like maybe where their test site is, you know, their new test site, or is it open to the public? Can Cybertruck owners go over there and actually see this 500 kW system working at play? What are your thoughts? Or are we still in the process of gathering that information?
Yeah, I think I noticed a while back a lot of the electric plans that were outputting already had created some room in the fact the specs of the equipment they're going to be installing. Of course, Tesla's a manufacturer, they have specific specs on it, but they also say that it might vary upon installation. And so they kind of allowed a little bit of room so that which allowed for the V4 pedestals to be, easily swapped out in that case because they specifically mentioned that in the plan set.
I
So
mean,
I think that that's already happened
I mean
for cabinets.
the V3 pedestals for the V4 pedestals, basically.
Yeah,
Once
so they
the
can swap out, last second if they need to. So really, I think it's going to be the UL. As soon as that UL is passed, and then they have cabinets coming out with the UL, stamp on it, and they can prove that to the AHJs or the permitting authorities that that will be key, and it'll be important as well for also, sometimes what they'll come back at a manufacturer or if we're installing a charger is the airflow requirements to make sure that they're met. So they would need specs on that, which they might have already, but some of that comes along with UL and some other standards and meeting those standards. So they're probably going through that process now. They'll need that documentation to successfully install these. So I think some of these regulatory points need to be overcome before they can start to get these in the ground.
Roger that. Now we know that we've done a couple urban superchargers, and we've seen that Tesla's had us put in 3-inch conduit, from point to point for like urban chargers, and so we're like, all right, well then maybe that'll be when they switch out the maybe the urban charger for maybe a V3 charger. But now, shoot, with the 3-inch conduit, you can switch out an urban charger for a V4 charger, no problem. Because they've planned all of that well in advance, well ahead of time. So that way they're not having to reconstruct and redig up an entire site in order to make this change. They just, swoop in, pull in, I guess, pull out and pull in at the same time. And then just replace the cabinets and replace the pedestals right then and there. So these are all good things and fundamental things that we try to expand to customers, and the insight with regards to like future proofing and scaling and kind of what all does that look like, not only to take care of where you're at now, but also where you're going to be at in the next 5-10 years. Tesla knows this is all that they do. And so this is all that we do. And so we've tried till we're blue in the face to try to explain some of this stuff to our customers. But honestly, with some customers, it's met with, no, we just need to take care of what we have and what we need to get in the ground now. But with others, I'd say about 10% of our customers, they actually come back and say, you know what, let's put in extra size conduit in there. Let's future proof and scale this thing out to where any type of expansion opportunities come away. We don't have to continue to or go back to the whole digging and the construction and all the civil that's resulting of this site. It should be pennies on the dollar for us to add more and more units as we go through. Kind of all get on board of the EV charging infrastructure movement. So really good things here. I'm wondering on the communication side if they're actually going to use Starlink. I mean, it just kind of makes sense, but I don't know if the latency is enough in the high population dense areas that we're going to see these V4 cabinets introduced first. If they actually will have enough, I guess, bandwidth to be able to support the communication.
I think they'll probably do both because it says in the specs 4G LTE, so it has the modem built into the cabinet. But I bet since it says Ethernet as well, it could just as easily be a Starlink connectivity as a secondary backup to ensure redundancy, and that's what I expect they'll do, or at least have as an option, depending on where it's located.
Yeah, it should be a no-brainer, man. As far as the cabinets, I mean, if you look at the we talked about the eye bolts, of course, the standard for eye bolt setup. From looking at it, I don't know if they flip up or if they're like kind of built in. And the traditional eye bolts, they basically sit on top, and they're kind of ugly. But this looks like maybe it's
they're recessed. It
high.
says recessed 1.5 inches into the unit, and there's 4 lift points in the fine print.
There you go. Very nice. Very nice. And so that will definitely help as you're taking the old cabinets off and you're putting the new cabinets on. Now, some of the things that I thought was odd here is the actual space at which it's taking up. This is taking up a considerable amount of space with regards to the regular pedestals. I mean, the regular cabinets behind the fence. So if you look at the fence, like what type of footprint do you think? This isn't a 4 cabinet footprint that 4 V3 cabinets would take. So I'm curious to see what type of, like, maybe there's a platform or some sort of play where if they're removing, let's say you have a site that has 16 V3 superchargers on it, and you have 4 V3 cabinets, behind the fence, and you're wanting to convert that site from a V3 site to a V4 site. Those conduits are specifically in the ground, and they're stubbing up at a certain point on there. And so I'm curious to see maybe take out 4 of those cabinets and only add 2 of these, and it should be able to. Is that what you're thinking would happen behind the fence? Like, how would we reconstruct behind the fence with taking out the old cabinets and putting in the new cabinets? What are your thoughts on that?
I think they would need to redo the entire pad, because the location of the AC inputs, DC outputs, I mean, those would need to line up perfectly, and it doesn't appear that that's the case here compared to the V3 cabinet. So that would need to be redone. The number of conduits coming in and out are quite additional, more than compared to V3. So that would need to be accounted for as well. So additional conduits run. So that's breaking up a pad and redoing conduit and redoing the pad as well from the beginning.
Maybe not the worst if you're having to re-pull the wire out anyway, right? You pull the wire out, you break up the pad, you chop off the conduit, and then you put back on the conduit the way that it needs to. But it definitely will take a little bit more of a redesign. But at least you're not having to trench and do all of that stuff. Maybe to be able to support the same amount of cabinets there. I don't know, but that I guess that we'll actually see that once we actually start putting these things in the ground and we start seeing more construction prowess on that. I thought the openings on the actual swing, the workplace clearance on the actual the door, seems like there's one cabinet access point here, but then you see this this right here. It seems like the corners come off and they sway out. So this door opens, and then
there's 3 doors. Yeah, if you scroll down a little, you can see that there's 3 doors on the front of it. So 3 latches, one in the center and then one on either side.
Curious to see what do you think's on the side doors? I mean, we know all the breaker and the switch gear and all that stuff, I guess is inside the middle part. But I'm curious to see what all we think access wise on the side. We don't have any visual on that until we actually get to see these things in person, which we'll bring to you guys. Of course, as soon as we see our first site locally here in town. We're in Austin, Texas, so we're pretty close to the Tesla Gigafactory. The problem is that we're not up in Buffalo, and traditionally what we've seen is as Tesla's rolled out the new V4 stalls to their sites, any type of pilot programs that they're doing, they typically do them closer to the Buffalo Gigafactory area, in the, kind of the New England area, and not necessarily here. But that could, I don't know, that maybe that changes or what. But we'll continue to keep our eyes posted on that. Any thoughts on the ground clearance or the workplace area clearance on here? I mean, you're talking, 60 inches. It's pretty
interesting. There's openings on the base where you can see where I think it'll be designed for a surface mount option, meaning like a temporary or having surface mounted either raceways or duct
coming in
raceways coming in and out via the side. So rather than having to have conduit coming straight out the bottom, meaning that you need to either custom build a pad or some sort of a foundation for it. In this case, you could have it coming out the side of it on mounting on an existing surface for probably more like a temporary supercharger or temporary semi, setup on, like we've seen on 18-wheelers in the past. We've even installed one of those temporary skids that are essentially set up in that way. They use specialized wire that's designed to have bend radius that can work within that tight environment. And so it looks like they had that in mind, and it'll allow for that type of configuration.
Now, looking at you're talking PFUs, prefabricated units. And so there may be some usage here where, it's coming in on a large. The problem with prefabricated units is like, this is great, but for an 18-wheeler to carry 4 on one side and 4 on the other, with a very large pad, that's an incredibly long footprint. So I'm curious to see if they were to do that. I mean, I
think it'll be front to back. It'll be like, 4 on one side and 4 facing the back side. So it'll be the same footprint technically. It'll just be wider, and it'll still fit on the trailer.
So you're looking more of an island type setup and design with your parking lot setup. Interesting. Okay, now you're getting into some fundamentals there where now it starts to make sense if you're able to do that. So that's pretty interesting. Okay, and as you're catering to more and more OEMs with different charge point locations, you see the advent of Rivian coming out with the NACS. Mercedes just released their stuff with the NACS and the CCS one. Don't even get me started on that charging port inlet and what that looks like. And then, of course, you have the Hyundai, stating that they're actually going to come out in 2025. We've had testament from all the OEMs stating that they were actually going to come out with the NACS connector port, in all of their vehicles. And so the question was, well, is it going to be in lieu of, or in retrofit? Are we gonna have a NACS on one side of the car and a CCS1 on the other, until maybe 5 years from now, maybe 2030 comes, and then we can all transition safely to the NACS standard? It depends. I mean, I'm seeing Hyundai, they're just going straight NACS from their outlook. I mean, from the way that their charging port looks, it's just NACS. That's it. It's the only thing that they have. So
I think the problem there is Mercedes already invested in their own network, and it has CCS on it. And they could change to the cables out, but to get those cables and do it in a timely manner, they didn't want. My guess is they just did it as a stopgap until they swap out all those cables. Once those voltages are swapped out, everything's NACS. Then they'll go full 100% NACS and nothing in between.
Okay, so yeah, so maybe like a gateway drug for the next 5 years until everything's stabilized. Yeah, until everything's stabilized. At least you don't have to worry about adapters like you talked about. Those are failure points inside that process. When you're dealing with DC fast charging, you don't want any failure points whatsoever on that end. But we did notice that inside the Mercedes that they actually had it was just the CCS1 combo connector and the NACS connector inside their charging port, which tells me that they are moving away from J1772 altogether on the AC side of things and just going with NACS. And so that's exciting, right? We know that super majority of charging, 90% plus, occurs in the AC realm, and not that much actually occurs on the supercharging side. And so to see the industry actually taking heed of that and actually moving all things AC on the NACS standard, that's really exciting to see some of these manufacturers as they come online. I wish that Tesla would have maybe possibly onboarded more and more of the contractors, the OEMs, faster, but we do understand it is a slower scaled ramp up because of the communication that has to happen in both the car, the charger, and all the charging systems involved. It'll be curious to see. I think we bet the team this morning or yesterday was if the ISO 15118 plug-in charge protocol is actually going to be included in the NACS port on these vehicles in 2025. So therefore, they basically operate just like Teslas do, where it's just plug in charge and that's it. You go, you plug in and you walk away, right? There's no authentication, there's no credit card swipe or anything like that. So curious to see if because they're moving fundamentally towards just one charging port and one connector standard, if we're actually going to see that. And then also there's a button, if you drive a Tesla, there's a small button on the connector that essentially has what is it? I don't know what type of signal.
It's a RF. It's a short range RF that will open up the charge door. Yeah.
Yes. And will that operate in the same fashion on these, will the OEMs absorb that same signal there to open up their stuff? Because some of them are just like push unlock and then you manually open. I don't think that, I don't know, who knows? I guess test the time. That would be
absolutely.
That would be very convenient. I don't have to go back in my car and push the button. I'll go back to my app and push the button to unlock the charging port. It's right here. It's on the actual connector,
Yeah, I mean, I expect they'll have that, and then I don't think they'll use ISO 15118. Most likely they'll just use the Tesla proprietary. It's just far more secure. It's set up in such a way that it's already well tested and well field tested in so many different ways and unhackable. They've done plenty of hackathons to try to get people to hack into it or just make sure that it's actually secure, and it is. It's not infallible, but in the grand scheme of things, it is the most successful and longest running by far plug and charge authentication and for payment processing verification. So that's successful. But what I'm really curious to see is now we have so many vehicles out there that are 400, 500 volt to 800 volt, We got Cybertrucks that can do, the super high speed up to 500 kW now on this new system running at 800 volt. But then we're going to have Model 3s and Model Ys and Model S and Model X pull up, and they're running 400 or 480 volt into their battery. Any fast charger out there today has a similar layout to this, where you have a central cabinet, multiple pedestals, that there's plenty that are capable of running both 400 and 800 volt output, but they can only do one at a time. They can't have one pedestal get 800 and the other one get 400. It's incapable of doing that. So that means that everything must only output to the lowest at 400 volts. Or if someone's charging at 800 and someone plugs in with 400, the 400 person has to wait until the 800 person's done. And that's where there's a couple ways to work around that and still make it so both can charge, but it's not ideal. So I'm wondering if Tesla has done something unique here, something in the switching on the DC side that allows one pedestal to output 800 or more and another pedestal to output 400 or 500 at a different voltage simultaneously. That's the key. No one that I've talked to on the DC fast charging side is capable of providing that today. So can't wait to see.
Well, we do know the DP DT switch that the Cybertruck has inside of it, right, allows it to have that 400 volt plus the 800 volt architecture, kind of included when that switch makes contact. So I'm curious to see possibly maybe using the Cybertruck as a test bed on that end, and then bam, it's proven. Let's go with the same use with all of our vehicles. But then you also have the advent of wireless charging and how Tesla's debuting that with their autonomous fleet. And soon, if they build the actual receiving pad inside the battery pack at form factor, you can see that they're going to be saving weight. It also becomes a structural part of the vehicle if you could put that pad there. So it adds more resilience, it adds more redundancy, and takes a little bit less weight for you to be able to add that technology on the vehicle, which we're super pumped on that end. So it was really interesting to see how Tesla has jumped from 72, 125. I think they've always been 125 on their superchargers ever since I believe 2012 when they debuted the first one. And so you're looking at out in California. So they went from 125 to 250, and now they're going from 250. They're not going to 350. Everyone thought that they were going to 350 kW on these chargers. Everyone, even Franz, and you saw Lars talking about the 350 capability and some of the stuff that they've actually. But now you see they just dropped a huge hammer on 500 kW. Like, I get it. Like, not that many trucks, not that many vehicles out there can actually take that much power. But knowing that the Cybertruck can, now you're starting to deal with C factor, like the C ratings on the batteries. Like, what if your battery can charge at 2C or 4C or 5C? Well, at 5C, at 500 kilowatts, that is very fast. Now you're starting to rival, filling up your Cybertruck from zero, to full in, 10 minutes. Like, that's unheard of. Like, zero to full in 10 minutes. Like, so as you start to see a lot of these incremental, power adjustments, and how Tesla just leapfrogs every single time they put something out, they leapfrog, they change the industry. You're going to start seeing every one of these 350 kW. Now everyone's going to try to catch up to the competition of these. So it'll be interesting to see how everything pans out in the next 5 years on how, other OEMs actually challenge and rival this 500 kW, hammer that Tesla just threw down. It is pretty exciting to see, man. We're super stoked. Do you have anything else you want to add to the audience here with regards to kind of the new latest greatest? This is the hot.
I think the biggest thing is just for existing Tesla owners, just to know that, hey, if you have a Model 3, Model Y, Model S, or Model X, that you won't see anything change. It'll be just like any other supercharger or V3. It doesn't matter if it's V4. So just know that. But if you do have a Cybertruck, you're talking about a 30% increase. You should see as far as charging rates. So that's pretty significant, especially considering, the efficiency is a little lower. So this helps make up for that and then some. So the actual charging rate, or RP, or range per hour, that it's capable of adding is in excess of far more than 1,000 miles of range per hour. Talking
1,300.
Exactly.
1,300 something. I was like,
so with Model 3, Model Y, you can get up to 1,000 miles of range per hour at 250 kW. With the V3, at it's low state of charge for a short period of time, right? But I think the Cybertruck not only will do it at the higher voltage that will significantly increase it. But then I think that'll flatten the charge curve a lot more, so it won't drop off as quickly like Model 3, Y, S, or X do. So that will be interesting to test once we start to see some actual real world testing happening.
Well, there you go, folks. Look, thank you so much to our listeners and subscribers today. I hope this episode has brought to you all just a little bit more value to your day. I know we're all better for it. Thank you so much, David, for joining us today. I love you guys. I can't do this without you. So please click the thumbs up icon if you can, share, comment, subscribe to our channel if you think we earned it. And thanks again for charging up with us today. Look, keep in mind, you can always find us at smartchargeramerica.com. And remember, folks, if you can't charge, you can't drive. We'll see you next time. Cheers.